Hello class, this is the last example on integration and calculating the area between two different functions. So when applying the sum or difference of integrals, there may be scenarios where both need to be applied. So I want you to go ahead, try and graph this and highlight the area that we are actually going to calculate in this particular question. Go ahead, pause the video and give it a go. In case you didn't see it, let's actually graph this line here. X equals 0 is just the line here. It's the y-axis. Let's make this a little bit thicker so you can see it. And the two functions are obviously already graphed, but the area between them, we're actually going to calculate these areas that I'm highlighting now. So this area here, that's the area between the two functions, as well as this area here. So there's actually a little bit of difficulty in this question, in that if you take a look, this function is clearly the concave up parabola. So actually let's avoid any confusion and let's label these. We have f of x and g of x. I hope you can see that this parabola here is g of x because it is concave up, whereas the purple one, that is going to be f of x. Notice how to calculate this area. It's actually g of x, which is above, and f of x, which is below. So in that interval, it's going to be, so call this area 1. For area 1, it's from 0 to this x value, we don't know, let's call it x1, of g of x, because that's the one above, minus f of x dx. G of x because it's above, and f of x because it's below. But then for area 2, this area here, notice how the functions switch as to what is above and what is below. So for area 2, it's actually going to be from x1, we don't know what that is yet, to x2 of f of x minus g of x. And the reason why they switch, just to highlight it again, remember it has to be the top interval, in this case f of x, minus the bottom interval. From this interval, f of x is above and g of x is below. But the previous interval, g of x is above and f of x is below. Hence why we have separate areas that we need to calculate. And notice how we have two different intervals we need to integrate. So let's solve the problem, because we actually first need to calculate the intersection of both parabola. So let's find that first. So x squared minus 8x plus 12 is equal to this parabola here. I'm just going to duplicate that, make it blue. Let's solve this problem here. Adding adding x squared, we get 2x squared. Negative 8x minus 4x, we get negative 12x. 12 plus 4, moving that 4 across, we get plus 16 equals 0. Dividing everything by 2, we get x squared minus 6x plus 8 equals 0. You can solve this whichever way you want. Quadratic formula, but in this case, I'm going to try factorize it. We get x. I believe it's going to be -4 and -2. -4 minus 2 is -6. -4 times -2 is +8. So that works. We get x equals 4 and x equals 2. So this point here is 2, and that point there is 4. So now that we have these, we can now calculate the areas that we are looking for. Let's call this area 1. Area 1 is g of x, which is, the interval we're looking for is from 0 to 2, 0 to 2, of g of x plus 12 minus, because remember, this is the top function, minus the bottom function, which is f of x. For this, I'm just going to copy everything out, put it inside the bracket, and make it blue, dx. Collecting like terms, integral from 0 to 2 of, being very careful now, x squared minus x squared, that's 2x squared, 8x minus 4x, that's going to be negative 12x, 12 minus 4, that's 12 plus 4, which is just 16 dx. So that's our first interval. And you can go ahead and solve that. That's the easier part. And for area 2, it's going to be f of x minus g of x, because it's going to be this one, f of x minus g of x. Let's make that blue. And I am forgetting some notation here. I need dx. And the interval for this one is from 2 to 4. Be very careful with that. A lot of students tend to just pick the same interval. Collecting all the like terms here. 2 to 4. Negative x squared minus x squared. That's negative 2x squared. 4x minus 8. That's 4 plus 8. That's still 12x. Negative 4 minus 12. Yep, negative 4 minus 12 is negative 16 dx. And these two integrations are what we need to solve. Go ahead, pause the video and give this a go, or you can skip right to the end to find the solution. So here we go. Increase the power by 1, divide by the new power, not forgetting the current coefficient, minus, increase the power by 1, divide by the new power, negative 12, minus, divide 2, 12 divided by 2 is 6, plus 16x from 0 to 2. Now it's just a matter of calculator work. Whoops. And let's do this. Minus this one here. And for this, we're going to be substituting two different values. The first one, we're substituting 2. The next one, we're substituting 0. This one's nice and easy. This is just all going to be 0, so minus 0. This first one's going to take a while to substitute into a calculator. 2 over 3 times 2 cubed minus 6 times 2 squared plus 16 times 2. I hope you're getting 40 on 3. So this first area, area 1, is 40 on 3. Solving area 2. Once again, it's the exact same thing. We get negative 2 over 3x cubed, because raising the power by 1, dividing by the new power, plus raise the power by 1, divide by the new power. That's 12 divided by 2, which is just going to be 6, minus 16x from 2 till 4. As a matter of space, I'm not going to write the whole thing. I'm just going to substitute it straight away for 4. So substituting 4, I get negative 2 over 3 brackets 4 to the power of 3 plus 6 brackets 4 squared minus 16 times 4. I'm getting negative 32 on 3. That's when I substitute 4. Now I'm substituting 2 in for all of them. So substituting 2, 2, and 2. I'm getting minus negative 40 on 3. Negative 32 on 3 minus 40 on 3. I'm getting 8 on 3. And lastly, we just need to take area 1 and add it with area 2. So in total, we get 40 on 3 plus 8 on 3, which is 48 on 3. Let's see if that simplifies. 48 divided 3. Yes, it does. This is 16 unit squared. So this is one of the harder problems when it comes to integration. So I hope that gave you an insight into how we solve a problem such as this. Hope to see you in the next video. Best of luck.